Dear viewers, a country once famous for cheap labor is now redefining the concept of construction with modern technology. Outstanding speed and unimaginable scale, from bridges spanning dozens of kilometers across oceans to solar power plants emerging in deserts. From high-speed railways covering mechanical tunnels kilometers deep in the mountains. China is proving that they build not only to serve people's livelihoods but also to change the global balance of power. Join us to explore each bold step, each great project and each giant machine that has helped China break through limitations on the world construction map in today's video. First, let's look at the road construction process, an area where China currently leads the world in total length. Every highway undergoes systematic and scientific implementation steps. First is overall planning and route determination. This directly determines the durability and connectivity of a route. Areas with weak terrain or unsuitable conditions will be reinforced or have their foundations replaced. Next, the foundation soil is excavated deep, compacted, and reinforced with specialized material. They are built layer by layer. Then the road surface is paved with hot asphalt or reinforced concrete depending on the area. Simultaneously, drainage systems, road markings, barriers, signs, and smart equipment are installed before official opening. A typical example is the G4218 highway, also known as the Highway in the Clouds, running from Chengdu to Tibet. This route crosses treacherous mountains, with sections built at over 4,000 meters above sea level, requiring extremely complex construction techniques. This is one of the proofs of China's leading road construction capability, both fast and solid. In places where the sun can melt the ground, humans have found ways to turn what seemed useless into valuable energy. It may be hard to believe, but in the vast desert, where sand stretches to the horizon, China has built massive solar power plants. Photovoltaic panels arranged in kilometers-long rows, operating like giant river fields capturing intense sunlight to convert it to electricity. The special feature here is the intelligent cooling system, helping the panels operate stably even when outdoor temperatures exceed 50 degrees. Meanwhile, the control system continuously optimizes operational efficiency, ensuring every drop of sunlight is utilized to the maximum. No smoke, no noise, no emissions, only light and electricity. This is a major step forward in the journey towards clean energy and protecting the living environment for future generations. When looking at 100-meter-long container ships docking safely amid big waves and strong winds, you imagine that the seaport where they berth is such a complex engineering project. To build a modern seaport, China typically starts with coastal terrain surveys and seabed geological analysis to ensure a solid foundation. Then, breakwater systems are driven deep into the seabed, accompanied by large concrete and rock blocks forming protective outer walls. Inside the port, the wharf area is reinforced with high-strength steel and concrete to withstand impacts from superloaded ships. Giant cranes and automated container systems are installed alongside cargo handling systems, warehouses, and domestic transport routes. The port net is also adjusted to accommodate ships with large drafts, with Shanghai's Yangshan port being a typical example. That's most modern deep-water ports capable of handling over 4 million TEUs annually. This is not only a transport hub but also a symbol of China. Dear viewers, when it comes to underwater construction projects, the biggest challenge is the constant fluctuation of water levels, currents, and hydraulic pressure. To overcome this, a special solution has emerged: the Phantom Marine Breakwater, an advanced technology likened to a steel shield protecting construction areas in isolated river, lake, and sea locations. The special feature of this system lies in its modern modular design that can be easily assembled, disassembled, and adjusted in size to suit all terrains. Thanks to its tight structure and high impermeability, the dam creates a dry, stable space for workers and construction equipment to operate safely without being affected by tides or strong currents. Therefore, this is considered an ideal choice for projects requiring minimal environmental intervention, from bridge construction, straightening rivers to wastewater treatment plants. In the future, the theft of marine breakwater will be an indispensable element in all water-related projects. A beautiful, clear and cool swimming pool, where people relax and recuperate, seems simple but is the result of an elaborate and precise construction process. First, the pool location and shape are carefully surveyed. The ground is excavated and shaped, then leveled and reinforced with reinforced concrete. This concrete layer must not only be sturdy but also have absolute waterproofing capability. Next comes the plumbing system, circulation, filtration, and drainage. All must operate precisely to maintain water quality. Finally, the pool surface is covered with tiles, mosaics or specialized coatings that ensure both aesthetics and user safety. At luxury resorts like Sanya in Hainan or in Chongqing, artificial infinity pools at high altitudes, overlooking entire cities, are increasingly appearing as clear evidence of the combination of art and technology in modern construction. Not stopping at ground level, China is also heavily investing in modern railway networks, including high-speed rail lines covering the entire country. The railway construction process begins with terrain surveys and site clearance. Next is the construction of drainage systems and crushed stone foundation layers to stabilize the track structure. Then steel rails are placed on concrete or wooden sleepers and fixed with specialized screws or clips. Signal, power and communication systems are integrated in parallel during installation. After passing all technical tests, the route is put into operation. The Beijing-Shanghai high-speed railway is a prominent example with a length of over 1,300 kilometers. With a maximum speed of up to 350 kilometers per hour, this route reduces travel time from 12 hours to just over 4 hours. This is an achievement that amazes even Western countries. Projects in China and Asia also carry the mission of reconstruction and protecting communities from natural, not only limited to bridge construction. Many projects in China and Asia also carry the mission of rebuilding and protecting communities from natural disasters. An emotional example is the Numa overpass in Miyagi Prefecture, Japan. This 1,344-meter-long bridge was built as part of a recovery plan following the devastating 2011 earthquake and tsunami. The 32-meter-high bridge connects two key areas with a cable-stayed system linking towers up to 115 meters tall. Not only structurally strong enough to withstand high-level tsunamis, Numa Bridge also impresses with its artistic nighttime lighting system, making it a symbol of hope for the entire region. This design approach has also been applied by China in many overpasses like the Hong Kong, Yuhai, and Macau Bridge, hoping to seamlessly connect administrative zones and major cities in the Pearl River Delta region. When mentioning tunnel digging, we often imagine workers with shovels laboring in the dark. But today, technology has completely changed the game. The tunnel boring machine, TBM, is one of the world's most modern industrial equipment, tens of meters long and weighing hundreds of tons. This machine operates like a steel worm, continuously drilling through hard rock layers with its cutting head while installing concrete segments behind to prevent collapse. A notable feature of TBMs is their ability to self-operate in hard rock masses without needing auxiliary support systems. This helps save significant costs and time. China currently uses hundreds of TBMs for projects like the Beijing Metro system, the Xicheng Mountain Tunnel, and the undersea tunnel connecting Fujian and Taiwan. If in the past, building a large bridge took years with many challenges regarding height, structure, and climate, today with German technology support, the process has become easier and faster than ever. From high piers to ultra-long connecting beams, every detail is installed following scientific processes, maximizing durable materials like high-strength concrete and load-bearing steel. Even when building in challenging terrains like deep valleys or lake beds, modern techniques ensure absolute precision in every weld and assembly block. Bridge support systems, including scaffolding, lifting frames, and auxiliary structures, are all optimized to help workers access construction sites safely. As valuable is that today.
Each completed bridge adds another link, opening new opportunities for goods, tourism, and more convenient travel for people. That's why bridges err. What could be more impressive than witnessing a heavy train gliding underground through what was once solid rock layer that no one could penetrate?
This is the achievement of modern tunnel construction, utilizing the most advanced technologies available today. First, the giant tunnel boring system breaks through each layer of soil and rock ahead, transporting materials out via conveyor belts. Then, load-bearing concrete panels are installed immediately behind the machine head to create a solid structure, preventing tunnel collapse during construction.
Particularly, remote-controlled and unmanned vehicle technologies are deployed to enhance safety, minimizing risks for workers in cramped, poorly lit environments.
What's even more admirable is the rapid construction pace, thanks to advanced installation techniques allowing kilometer-long projects to be completed in short timeframes. Whether mountain crossing tunnels, river tunnels, or urban tunnels in crowded cities, every project is executed with centimeter-level precision. It can be said that tunnel construction is opening a new field for engineering, allowing humans not only to conquer the skies but also gradually tame the underground for life service.
Next, if transportation systems are likened to blood vessels flowing across the Earth's surface, then underground pipelines are the silent veins nourishing the entire modern economy. Today, building large-scale pipeline systems no longer relies on human labor as before.
Every stage is performed with modern technology.
First, the site is excavated with large excavators.
Then each single pipe is precisely welded by robots, ensuring tight seals and durability. External protective coatings help pipes withstand soil pressure and corrosion over time. Particularly, sensor-based inspection systems and remote monitoring robots help detect leakage signs early, something that used to be problematic in the past.
The entire process is fast and neat without disrupting natural landscapes. This is the image of modern infrastructure construction, silent yet powerful, protecting the lives of millions above.
When seeing smooth roads with few potholes, traffic jams, or accidents, you imagine the technological revolution behind them. Today, road construction isn't simply laying asphalt and waiting for it to dry. Everything is carefully calculated from the first step.
From compacting the base layer with Super Duty equipment to using special additives that increase surface hardness and elasticity. Automatic leveling machines create mirror-smooth road surfaces. But more remarkably, these roads integrate smart monitoring systems, like electronic eyes,
recording traffic density, providing early accident warnings, and suggesting repair solutions before incidents occur. With fast construction speed, reasonable costs, and long-term maintenance capabilities, modern road technology not only provides convenient travel but also helps build more livable cities in the future.
Dear audience, when discussing projects that change economic landscapes, we must mention modern seaports, where giant ships handle hundreds of thousands of tons of cargo daily.
To build such a seaport, humans must start with extremely meticulous processing.
First is ground treatment, where former swamps or shallow waters are stabilized using modern CDI technology, preventing subsidence and bearing heavy loads, followed by constructing piers, warehouses, and cable systems.
All assembled with steel and reinforced concrete, both durable and resistant to sea salt corrosion for many years. But what's most impressive are the massive machines deployed, floating cranes that can lift 40-ton containers in seconds. Automated cargo handling systems moving like giant ant colonies, fast, precise, and nearly error-free. Additionally, all port operations are monitored by AI cameras and smart coordination centers, ensuring absolute security particularly in the context of increasingly evident climate change. Modern port projects also integrate environmental protection solutions. To avoid ecological waste, the area is planted with seagrass, algae. It is not only a docking place for ships but also a symbol of technological advancement and sustainable thinking in a new era.
To block millions of cubic meters of water from a raging river and turn it into an energy source for a vast region.
humans have had to create magnificent structures, which are the giant hydroelectric. The construction process begins with a seemingly impossible task, diverting the flow of an entire river. With the help of super large excavators, people dig deep into the riverbed, set up temporary dikes to divert water to a secondary channel,
thereby creating conditions for the construction of the main foundation.
Next is the foundation treatment phase, which bears the entire pressure from billions of tons of water. Engineers use high-strength concrete, combined with special steel supports driven deep into the ground to form a solid backbone for the entire dam body. Each layer of the dam is slowly raised, poured, and compacted with modern technology, ensuring absolute firmness and water tightness. Inside the dam body is a complex system of gates, pipes, chambers, turbines, and control rooms. These devices are operated by an automated system that can monitor water levels, regulate pressure, and control power generation accurately. Each turbine in a dam can be taller than a 5-story building, and with just one rotation, it can generate hundreds of megawatts of electricity. And finally, when everything is completed, the reservoir is filled with water, and the giant turbines officially start operating. From that moment on, the once fiercely raging water is tamed, becoming a clean, sustainable energy source serving millions of households downstream.
Looking at a completed dam, we not only see concrete and steel but also the vision, technology, and will of modern humans to conquer nature.
Along with the seawork system, large-scale energy projects are also becoming symbols of the remarkable development of 21st century infrastructure. From scorching deserts to windy mountainous regions, humans have learned to utilize natural resources, not to exploit them to exhaustion, but to create clean, environmentally friendly energy. A large-scale energy project has been developed for modern humans, and we have learned to utilize large-scale energy to create clean, environmentally friendly energy. Modern humans can create large-scale energy, often starting by clearing hundreds of hectares of land, building infrastructure like transmission lines, management systems, and then installing giant wind turbines or solar panels stretching to the horizon. Modern factories are equipped with high-speed wind turbines that can turn gusts of wind into electricity, while in areas with large rivers, people build hydroelectric dams hundreds of meters high, storing water and scientifically regulating the flow.
Notably, the Cell-KO app transmission systems can now bring electricity from the most remote areas to large cities with minimal loss.
Each such project could provide electricity to millions of households, an unimaginable number compared to 10 or 20 years ago. And more importantly, this entire energy production process is almost pollution-free, contributing to climate protection and preserving livelihoods for future generations.
In large construction sites spanning dozens of kilometers, where highways, airports, or key transportation routes are being built meter by meter, there is a machine that plays a pivotal role: the Super 3000 Bay, a new generation road paver from German technology. With its massive size and advanced electromagnetic control system, the Super 3000 Bay can lay wide and long road layers in a single, something that previously required many steps and a lot of time to complete. This machine possesses an extremely powerful engine, allowing it to operate continuously in harsh sunlight, heavy rain, or rough terrain. But most notably, it features an integrated slope control and paving thickness system, so each road layer laid is perfectly flat, accurate to the millimeter. An extremely important factor for high-speed routes, where even a small bump can be dangerous for vehicles. Not only powerful, the Super 3000 Bay also saves costs over the short construction period and reduces the number of workers needed. Thanks to smart machines like this, large-scale road projects no longer take years to complete as they used to. In just a few weeks or months, a highway dozens of kilometers long can be put in. With the presence of the Super 3000 Bay, the infrastructure construction industry has entered a new era, where speed, quality, and precision are maximized. This machine is not just construction equipment but a vivid testament to how technology is helping humans conquer time and space. Dear viewers, while the rest of the world is still debating where to start, China has already finished building. Building from the ground up, from deep forests to deserts, turning ideas into real projects, and not just one but hundreds of super projects simultaneously. Each one makes the whole world wide-eyed, and the superpowers are scrambling to catch up.
Don't forget to subscribe to the mystery_core TITODNAM Explore channel.
Hello and see you again in the next explorations.
Subscribe to the mystery_core TITODNAM channel.